Hi there. I'm Ray Krug, product marketing for NETSCOUT, and let me introduce Josh Dean, who's our partner solution architect for AWS, and he's been instrumental in helping us create integrations into some of the AWS services, as well as help with our migrations to AWS as well. And today I want to talk about it's a technology presentation where I want to talk about NETSCOUT patented technology for deep packet inspection to deliver both network and application troubleshooting and advanced network detection and response. And through that presentation, I want to talk about why it's advanced and how our technology solutions complement what you might already have as solutions for securing and assuring your AWS cloud migrations. Anyway, over to you, Josh, to talk about AWS cloud migrations.
Awesome. Thank you, Ray. So just by means of introduction, I'm, like Ray said, my name is Josh Dean. I'm a partner solutions architect at AWS. So what that means is I get to work with cool partners like NETSCOUT. So always fun to work on new technologies and see what's going on out there. So I'm glad to be here. All right, so just want to give a quick overview of kind of how we look at migrations, right? There are obviously lots of different reasons why migrations happen. Some of those are financial. Some of those are, because you want to get things out the door quicker. You want agility, any number of reasons. And I'm guessing if you're here, a lot of you are familiar with AWS. You've probably done some degree of migration. Could be small scale or large scale, anything, right? So this is kind of the migration process, right? As we see it, you go from assessment to planning to migration to operations and optimization. Now, as you'll see kind of as we go along here, Ray will explain how NETSCOUT helps here, but a lot of the time, securing these migrations and also making sure you're getting optimal performance is very difficult. And that's where partners like NETSCOUT come in. So before we get on to that, I just want to take a look really quick at kind of the security side of it and how we look at that here at AWS. So first of all, this is what we'd call kind of the traditional on-premise security model. You may have seen a slide like this. If you're operating your own data centers, you're responsible for everything from the hardware, the racks, up through application security, all the way to the top, right? With AWS, we have what we call the shared responsibility model, shared security model. You may have heard it that way. Basically, what that means is AWS is responsible for security of the cloud, essentially running the hardware, the infrastructure, making sure those are secure. Now, that leaves you as the customer to be secure in the cloud, right? So that can be anything from configuring security group rules, making sure S3 buckets aren't wide open, making sure you're patching servers, those kinds of things. Now, this is where partners like NETSCOUT come in really handy with security because they help make sure that you are not leaving things exposed, right? They help make sure you're following best practices, help you identify things that you might be kind of leaving out there, right? And so with that, I'll let Ray kind of explain sort of what that looks like.
Yeah, and thanks, Josh. And the problem happens when it comes to not necessarily the fact that you've migrated to the cloud, but the fact that now, most likely, you're going to have a hybrid environment, things on-prem, things in a colo, things in the cloud as well. And that means there's a lot of different management solutions and components that you need to operate in order to secure and assure your environment. And people are disappointed because it's just difficult to collate all that information from all these systems to make that happen, as it says here, to have a dynamic day two operational system. And of course, at NETSCOUT is all about visibility, and that's critical to ensure successful migrations from both a performance and a security perspective, so as Josh was saying. So it's all pretty obvious, actually, when it comes to the cloud migration. If you think about back in the old days, showing my age now, when you had on-prem data centers, physical servers, physical networks, you could see, feel, and touch them, and if something went wrong, you knew where they were to fix them. Of course, the advent of the cloud brings all the goodness that cloud services give you as well. But equally, it kind of gives you a bit more of a headache because you end up with a hybrid model. Things in on-prem, things in colo, things in the public cloud, connections, SD-WAN. That's today. So when it comes to a problem in that environment, where is it? Somebody's saying it's slow today. Oh, that's helpful, isn't it? What part is slow? Is it something in AWS? Is it something in the colo? Is it something on-prem? Is it to do with your migration that you've left things behind? Anything could be to do with that. So who has ownership? How do you escalate the problem? Now you've got different domains handling that. In terms of migration, you've got day 0, and then you've got day 3. What's the improvement of performance, let's say, now that you're in the cloud? And of course, last but not least, from a security perspective, your attack surface is now bigger. So there's lots more things to take a look at so that you can see if somebody's infiltrating something or somebody's exfiltrating something outside or there's lateral movement. So it's just much more complex, and there's a lot of tools to help you manage that. Visibility again. Visibility across all these borders is key to being able to give you that ability to see what's going on and handle it and escalate appropriately. So that's where NETSCOUT comes in, and we've got this tagline called visibility without borders, and that's exactly what we provide. These are customers, lots of logos there. We've got thousands of them. So that's important, of course. We've had successful cloud migrations with customers. But what I tend to talk about with these is the NETSCOUT technology allows you to solve the thorniest of IT or network problems in the most complex, largest of networks that are out there distributed all over the place. And that's kind of what we're about, both for service assurance and for security solutions, to have that broad visibility, that visibility without borders. So it's all about technology. So visibility without borders starts off with the fact that we use deep packet inspection. We use packets that are available anywhere and everywhere and give you that true meaning of performance and security, because packets don't lie. They're everywhere, and they're to do with all the communications that take place across your hybrid environment. So it's any service, any network, any cloud, any vendor, because packets are independent of all of that. And what we do, I talked about our technology, we do that deep packet inspection, we do that at scale in real time to translate the packets into meaningful metrics. Availability, reliability, responsiveness, quality, security metrics. So we take away the pain of the fact that packets are just difficult to interpret. There's so many of them, and it's so hard to do. We take that all away and provide you metadata, metrics, to allow you to solve key problems in terms of performance of applications, servers, infrastructure, networks, and also monitor that attack surface to see what's going on. Question, of course, is how we do it, I suppose, what we do. And as I've said, this technology is patented. We call it ASI, and it's Adaptive Service Intelligence. So that's a patented technology to deliver that deep packet inspection at scale to provide those metrics. And let's take a look at the problem of doing that. And this is the thing that NETSCOUT have taken away from what you need to do. Because, yes, we've said that packets are very valuable, and there's a lot of them. So how do we do what we do? That's the interesting thing. So you have packets, and I'm going to draw a pyramid of volume of data. And we are able to take those packets, store them. Of course, that means there's a lot of data, so we can actually store them intelligently. We can compress them intelligently. So it's not just a case of slicing those packets, which is perhaps the traditional way of reducing the size of the storage of packets. But we're able to take on a per protocol basis to just take the goodness out of those packets, but still keep the format of the packets. So you can keep longer term information of packets. And okay, that's all I'm going to say about packets in principle, but because when it comes to workflows to do service assurance or security, you don't want to be looking at packets, and you don't necessarily want to see those packets because then you've got the headache of interpreting them. So further up the pyramid is where we do our real-time analysis of those packets to give us our metrics. And we bring up the pyramid, and we actually start to see the first level of metadata that we provide. Take those packets, and then we store all the transactions of those packets. So that's like every DNS request and response, every HTTP request and response, logins, authentications. So we have a set of metadata which gives you that goodness of the packets without the rubbish, let's say, the length of packets and stuff like that. So we store that, and those become really useful for mainly security use cases. If we can see, for example, every domain that's been looked up, you can imagine the power that will give you in terms of understanding, rogue sites that are being accessed by their users. Further up, conversations. So if you think about conversations similar to NetFlow, so that gives you who's talking to whom and what application, what volume of traffic. So that's pretty useful stuff because it allows you to see, historically, what's been going on from a perspective of security, maybe some lateral movement that might be going on. But of course, when it comes to performance use cases, it's not particularly useful because it doesn't give you things like latency or performance figures or errors and that sort of thing. So that sort of conversation data has its purpose, and it's very useful. But sometimes when you're looking at both security and service assurance use cases, it doesn't necessarily cut it. So at the top of the pyramid, let's call this the goodness. This is what we call smart data. And what this is an interpretation of that metadata for a series of metrics, key performance metrics. How fast is the server? What's the latency of the network? From a security perspective, what IOCs have we compared with? What's the application performance? What's the network performance? And those sort of aspects. So we get to the top there, which gives us intelligent metrics, smart metrics. And of course, what can you do with smart metrics? Smarter analytics. So anyway, so that's the way our pyramid's built. And you can see that we then, on top of that pyramid, we actually provide some workflows and applications to actually use that metadata to solve both security and service assurance problems. And when I come to think about the problems that this technology allows you to do, it's like extremely versatile. And we'll start like drawing a clock here. And the obvious one is network performance management. So we're monitoring the network so we can see how it's performing. So that's pretty useful. Capacity management, latency of the network. So if the problem associated with, it's slow today, is to do with the network, we have metrics for you to say it's the metric. Application performance management. This is interesting because packets are not necessarily related to the application or the APM marketplace. But what's very interesting is when you interpret those packets, you get a sense for, application latency, server load, server latency, and a whole bunch of other metrics that we can extract from those packets to actually say, hey, this is the server and the application component that's actually slowing down rather than it being the network. So being able to differentiate that really helps when it comes to troubleshooting problems because it helps you locate the problem. Look at the network. Don't look at the server. Don't look at the size of the EC2 instance. Look at the network infrastructure that's going on. So very powerful set of utilities. Again, another area that we monitor and we have got deep knowledge in is unified communications. So this voice and video traffic and understanding how it's impacted by packet loss or network latency. So we've got some deep knowledge as to what's going on in the unified communication world, which is, of course, as you know, very latency or packet loss sensitive. Similarly, VDI, we have the same concept there. Again, very latency sensitive, things like ICA protocol or whatever you're using. If there is things going on in your network, you kind of want to be able to distinguish that and then attribute the problem with your VDI being slow as to be network. But it's kind of more important than just the network. It's other application components as well that are revealed when you look at the network traffic. And it's for all these use cases here. It's not necessarily focusing on the protocol for Oracle, the protocol for video, the protocol for web. It's about other things that are also going on, like DNS, those unsung heroes, the service enablers. If DNS isn't working properly, then your application won't work correctly either. You'll be timing out. You'll be losing connection. You won't be able to log in, and those sort of aspects. We are monitoring all of that, so when it comes to troubleshooting your application, no matter what application it is, we're kind of pinpointing you in the direction of what you need to be looking at. Don't look at your Oracle server, look at your DNS, because every time you're trying to access this server, you're getting DNS errors, as an example. Last but not least, of course, cyber. And I talked about advanced network detection and response. We're looking at the packets, seeing the volume of packets coming in, seeing what they're doing. And then we've got a seriously cool solution for looking at DDoS, for looking at cyber threat analytics, and cyber security as well. So this technology is just so versatile and so broad, yet it's using the single source of truth, which is the packets, to deliver these metrics and these solutions for you. So another thing on smart data. OK, one thing I wanted to mention, of course, the important thing about packet data, number one, it's Ultra HD. It's telling you what's going on. Every interaction that's going on is giving you that information, if only you could interpret it. So that's what we do. The other thing about it, it's universally available. So whether you're in the cloud or on-prem or in a colo, at home, it's all the same. So it's universally available across all these borders and becomes super intelligent when you convert it into that ASI, that smart data as well. So we've got to acquire those packets. And in whatever technology you're deployed in, we need to have ability to do that. So if we think about a traditional data center, probably all of you using VMware of some sort of environment like ESX or whatever it is, or potentially NSX. Those technologies offer port mirroring technologies. NSX offer the ability to do service insertion, and we support service insertion to be able to get access to that east-west traffic in these highly secure, zero-trust NSX-T environments. So we have that integration into those virtual platforms as well. And of course, even in a traditional network, we can support. Historically, we've done this forever, of course, is port mirroring, spans, and taps in your infrastructure as well. So on-prem, we've got that covered. You deploy that visibility of the edges or in your data center or in your branches or wherever it is that you want to do that. When we move across into the cloud, AWS, a great partner of ours, have an amazing technology, VPC traffic mirroring. And I remember working in the early days on the alphas and betas of VPC traffic mirroring to make sure that our technology could use VPC traffic mirroring to get the packets and then translate them into the metadata and then do all the good stuff that we do as well. So that was a fun project I had. Do you know, I'm thinking 2017, but time flies. OK, so we have visibility in AWS using the VPC traffic mirroring technology as well. And VMC, again, it's VMware in the cloud. It's pretty much traditional VMware technology that you have port mirroring, port groups that you're able to mirror the traffic there. And of course, if you don't have access to mirroring technologies, then we have a flexible deployment methodology. It's kind of an agent, and it deploys inside your workloads, in VMs, in containers, in pods, and it actually allows us to see the packets coming in and out of those devices or containers, and then do our good ASI smart data interpretation on that. So again, as you can imagine, visibility without borders, we need to be able to get extra access to the packets. As soon as you've done that, happy days. We then translate it into that smart data. And we do that with a technology called vStream, that's virtual, that deploys into AWS through the marketplace. And that's the virtual appliance which takes in those packets and translates them into that metadata as well. We also have on-prem versions of this. We call that ISNG, InfiniStream Next Generation. So they're physical appliances that we can deploy, 100 gig devices, and take in those packets and translate them into that metadata. So we're applicable on-prem, bare metal, virtualized in the cloud. We've got our smart data. So that's part one of what we do, that metadata. Part two, of course, is I've talked about the use cases that we support earlier on, and we have then platforms over which that smart data is received. And for advanced networking and application troubleshooting, it's Ingenious One. is the name of that platform. And for the advanced NDR, it's Omnis Cyber Intelligence. I'll talk about those in a little bit more detail in a second. But we've got a third one. And the third one is the concept of allowing you to take this metadata and do whatever you want with it. So stick it in your data lake, do your own machine learning and analytics on it, allow you to enrich that information and create smarter outcomes. So again, we've got those three things, and I'll just run through each of those individually in a minute. But back to what Josh was talking about earlier about cloud migration and our applicability there, and we've gone through the modernization and whatever it's called, migration competency. And that's where AWS put us through our paces to make sure that our customers can use our technology to do that migration with confidence. And if you think about it, okay, day zero, pre-migration, instrument on your on-prem environment, take a look at what's going on, ensure what's the performance, ensure your dependencies, because we can see everything. So we can see what's talking to what. We can then say, okay, what are the workloads that you need to migrate if you're doing a lift and shift? And then make sure that you don't leave things behind. So that idea of understanding the baseline performance, what you need to move, helps you define your migration strategy. Then day one, you're on to starting to do the migration. So what do you want to do there? You want to migrate into the cloud, continue to monitor, because you want that cloud migration project to be signed off, to be successful. How do you measure that? So it goes up into the cloud, check the performance, check that everything's working. Happy days, you're up and running. But there's another benefit there as well, of course, is if you're forgetting to move things, perhaps, you've not followed your migration policy, you've left the database behind, you can actually see the performance of what's going on. Now you're long-hauling that database traffic or that application traffic now from the cloud to your on-prem environment. So that constant visibility of those dependencies and the performance really helps you optimize your migration project and ensure that you've had success of the project, you've signed it off, and you can move on to your next one. But of course, things are constantly changing. You don't like sign off a project and that you're done, because then the next thing comes, and it's probably everything's happening and moving at the same time. So post-migration is that constant change again. So you want to continually optimize the performance, continually check that your new thing that you've moved doesn't affect the performance of something else. Monitor that service availability, monitor the service performance. So our technology, because now we have packets in that end-to-end view, as it were, allows you to continuously monitor it. You're using the same technology that you use for migration visibility. You can now use for that business-as-usual environment. And, of course, the last point there in terms of visibility is monitor vulnerabilities and security threats. And the point there is, okay, now you've got a bigger attack surface, you've got a bigger area, you've got more domains. You need to be watching what's going on to ensure what's happening. So that's what that technology allows you to do from the context of migration. So what I wanted to do is now hand it back over to Josh to talk a little bit about AWS and NETSCOUT, the partnership and some of the work that we've done. And then I'll be back. Thanks, Josh.
Yeah, thanks, Ray. So just really quick, just to kind of give you the overview of how we work together. Various different ways. Obviously, the most important for a lot of us is in technology alignment. So as Ray mentioned, he worked on sort of alphas, betas of VPC traffic mirroring, even services like Gateway Load Balancer. NETSCOUT really proactive in getting ahead of that, understanding how it works so that they can monitor data there as well. VPC ingress routing is another one. Obviously you want to take in that internet traffic, got to have some way of monitoring that as well. And then you'll see down there AWS Security Hub integration. We'll talk a little bit more about that in a short while, but essentially where in AWS can you aggregate and put those security findings that you generate. So AWS Marketplace offerings. Obviously, if you work with partners a lot at AWS, Marketplace is a great way to transact those deals. You can see they have offerings in commercial and in GovCloud for Marketplace. They participate in our customer engagement program. So that's where sales teams from AWS and NETSCOUT will work really closely together. Just make sure you're getting the best experience. And then partner designations. So Ray mentioned migration and modernization. You'll see there as well they have a networking competency. Makes a lot of sense. And you see there's a couple in progress, Outpost ready, Wavelength ready, and we're working on security as well. Yeah, so that's what I wanted to say. You can see some of the other designations there, public sector partner as well. Yeah, and back to you, Ray.
Brilliant, thanks. Thanks, Josh. So what I wanted to do is just follow that with like, okay, putting this a little into a practical architecture perspective, because I've obviously talked about packets and converting them to smart data and talked about how we can acquire packets, but let's kind of put this into some sort of visual, some sort of network architecture. And I kind of wanted to start with the idea of saying, okay, we've got, okay, users on the left there, or is it the right? No, it's the left. Communicating with either workloads in AWS, EC2 in this example, or workloads or VMs in your data center. So we've got that hybrid environment now that needs to be monitored. And I just wanted to quickly run through how we can get that visibility across those different borders and how we can bring them together to get that overall view. So if we start on-prem and imagine you've got VMware, let's say, so we've got spans and taps and NSX, service insertion, you name it, we get the visibility of those packets from that perspective. Those packets feed into, I've put in here vStream and ISNG, if you remember there, the virtual appliances or physical appliance, which is taking those packets and translating them into that smart data. Okay, so that's great. Then we've got, that smart data goes up to our platforms, as I talked about, relating to performance in Genius One, and cyber intelligence, Omnis cyber intelligence, which is the security NDR side of things. So what it means is that your vStream is actually kind of behaving in sort of two modes. It's doing the packets and then translating into relevant smart data associated with the platforms that are going to be you're using for managing service assurance or security. So it's kind of like a schizophrenic thing, and you switch on whichever ones that you want to do. So with Omnis Cyber Investigator, we're using that to detect anomalies in your network. We're using that to detect security impact. And we actually have feeds that we can actually, real-time feeds that we get into that to identify specific incidences of compromise. And we have a team that's taking a look at probably 1/3 of the internet traffic worldwide. So that's a huge chunk of information that they're analyzing, and they're discovering these bad actors or these bad sites that are actually appearing. And what they're doing, they're using that to create an intelligence feed that we use to investigate whether that's going on in your network, in your infrastructure. So that's quite impressive technology. We can obviously use the cyber intelligence to export its events to third-party sort of SIMs, for example, including Security Hub as an example. And Josh will go through that in a minute. So that's sort of part of the architecture from a perspective of on-prem monitoring for both service assurance and security. But let's extend that now. As I mentioned before, as you migrate to the cloud, you migrate workloads to the cloud. However you're doing that, as you can see those EC2 instances up there. So what do we do to monitor those? Number one, we can stick the vStreams up in the cloud. On the marketplace, as Josh was talking about, just deploy that. It's ready to go. And then you implement VPC traffic mirroring, again, from those EC2 instances and mirror that traffic to the vStreams directly if you want to do that. Or, of course, you can do it through a network load balancer, in which case at the back end of those load balancers, you have multiple vStreams, and that's for scalability and manageability. So you can choose to implement that way. There's also a third way that you could implement it through a gateway load balancer endpoint. And that's a particularly interesting one because, again, it allows the gateway load balancer to receive packets from mirroring and then send those packets to back-end vStreams. But what's interesting and different about that from a network load balancer, it's kind of a service endpoint. So the idea is that you could be sending traffic from one account and sending that into another monitoring account and receiving those packets like magic. And it is magic. That's one piece of magic I like about AWS. Anyway, I won't get boring. So the other mode of the gateway load balancer is, of course, the whole idea of the gateway load balancer is to have a fleet of firewalls or IDSs or whatever it is that you might want to do to scale up your back-end applications. And what we can do is obviously mirror those back-end servers with VPC traffic mirroring and mirror those and send that traffic to the vStreams. So it builds up a nice, it looks like a complicated picture there, but that's because the AWS infrastructure is so rich with the ability to get packet acquisition sorted. And then our technology leverages that to provide that rich, smart data across the AWS environment. So now I'm just going to talk about packet acquisition in those environments and an architecture in a hybrid environment. Now I'm just going to delve a little bit deeper into the ingenious one, which is the service assurance side of things, the advanced network and application troubleshooting in this context. And okay, smart data, you know all about that now. Technology, done. So what we have is a bunch of workflows that we can leverage that smart data to produce that smarter analytics, those visuals, dashboards, monitors for individual applications, dependency mapping. We can actually show you a dependency. I talked about that in the side of the day zero side of things, the idea of saying who's talking to whom, and we can map that out and allow you to see what's going on. So that's extremely powerful. Lots of discovery going on because at the end of the day, it's packets coming into us. We're seeing that smart data. We're discovering what is going on in your infrastructure and how it's all performing. So that's just what we do all day long. And a bunch of reports, okay, that's great. But we also have a bunch of alerts and some machine learning technology where we're looking at that smart data and deducing things that are going on, whether they be baseline or threshold-based alerts or cause and effect. So a good example of that, server is slowing down because there's an increasing number of transactions. I know that's a simple one, but it's an easy one to understand, and we're doing that sort of thing just to pinpoint things that are odd or going wrong in your infrastructure, allowing you to start pinpointing root cause. The other thing that we've got there is like a Google-like search. And this is it's kind of amazing, really. It's a pretty obvious thing to do, is that if you think about, we're looking at this whole environment, you could type in an IP address of a server, and we could tell you everything that's doing. Who is it talking to? What applications it's talking to? How much data? What's the latency? And all that sort of thing. So it's just such a simple but great workflow to allow you to see what's going on and why things are not performing. And that maps very closely to what network operations do when they actually see the hint of something going wrong from a particular server in the environment. And then, of course, right at the bottom there, you've got packet forensics. So we're not all packet experts. I certainly am not. So I don't really want to go to packets, but it's there. And then what happens is if our smart data has detected something wrong with a firewall going wrong or a server going wrong, then maybe that evidence that we can provide about that, if we provide that in the form of a packet that can be interpreted by somebody who understands that and can get into those deep, thorny issues that often can go undiscovered for months, but is causing so much pain. So it's there for the experts, but the richness comes from the smart data to tell you where to look. And of course, it's driven by patented ASI technology, which you know all about. So what I wanted to do was just relate this to the word advanced. And it's just a way of differentiating what's going on and how our technology is complementary to whatever you might already have in this arena. So if you think about service assurance and performance with current tooling or current visibility, they're broken down into the categories on the left there. So they're infrastructure-specific metrics like, okay, CPU utilization, memory utilization, that kind of thing. Other things like logs, that's a common way to actually take a look at what's going on in your infrastructure. Another one is NetFlow, VPC flow logs, giving you that volume information of data that's happening. Code injection. Okay, that's a common one where you actually write into your code some performance metrics and see what's going on. And finally, synthetics. So there's a lot of stuff out there which is trying to help you solve problems that are going on in your infrastructure, loads of it. And they are all necessary tools to be able to fathom things out. So, okay, what's so great about smart data then? Well, this is what's great about smart data. It's universally available. So, as I mentioned before, packets are everywhere. We do the same interpretation of those packets no matter where your workloads are and what they're communicating to. Therefore, we have the overall visibility of what's going on with a consistent view. So that's number one. Whereas if you think about infrastructure-specific stuff, you'll have something for your AWS stuff, something for your VMware stuff, something for things going on a firewall. They'll all be different. And you have to translate that into something that's common in order to get that view as to what's going on. So that's kind of one perspective there. The other perspective is the idea of saying, okay, if I know that my CPU is running at 60%, that doesn't tell me that something's slow. It just tells me that the CPU is running at 60%. Or if my memory is running at 90%, it doesn't tell me that that server is slow. It just tells me that my memory is running at 90%. Okay, and that might be normal behavior, and it might be perfectly okay. So with our ASI technology, we're seeing the interaction of those servers to what's going on. And we're seeing whether it's slow. As I said before, we're seeing whether the network's slow, whether the application's slow, whether the server's slow, and whether the server's busy. So we're able to say, okay, this thing is slow. Then what you can do, so we give you that alert, and then you can go to the infrastructure tools to investigate what's going on. And then say, well, oh, actually, this EC2 instance is a T2 micro. Oh, damn it, it should have been a medium, or it should have been a large, or whatever it is. Oh, I missed that one. But in your sea of 1,000 EC2 instances, spotting that is sometimes quite hard. But we're allowing you to direct to those environments. The other thing, independent data sets. So that's kind of interesting. Packets tell you what's going on. Packets don't lie. Okay? So a log, a DevOps log is written by someone to say, okay, something's going on here. That could go wrong. So because that's written by a human being, let's say, it's possible that it's going to give you inaccurate information about what's going on. Whereas packets don't do that because they tell you what it is. Again, packets are the source of truth. Real-time analytics and packet-level detail, okay, that's just sweet sauce, isn't it, in terms of, okay, if you need that evidence, you have it there for you, but it's so rich to be able to go into and delve into it. So that's a couple of things that I want to mention there about that advanced nature of what we do and how that therefore complements anything that you have already in your infrastructure or the multitude of things that you have already monitoring that environment. So that's the advanced application troubleshooting component. I wanted to speak about that. So what I want to do is move on to security now. And I talked about the Omnis cyber intelligence platform. And kind of what I wanted to cover here was the idea that we're monitoring in real time everything that's going on in your whole environment. So that's advanced early warning because we're seeing everything. We're doing that continuous attack service monitoring because we're just monitoring everything, and as that surface evolves, we see more. So you get that insight into what's going on. And then the other aspect, of course, that we're focusing on is that contact tracing or the back-in-time investigation. So the idea, okay, we've spotted that something is got malware, let's say, because it's accessing command and control. Okay, brilliant. We can focus in on that. But what we can then do is see who else has that server been communicating with. And then we can actually do that back in time so that we can say, well, okay, that's been infected. Maybe some of the other things that it's been talking to have also been infected. Maybe there's been some lateral movement. Maybe there's been some exfiltration. But because we can track that back in time, and we have that metadata to do that, we have that visibility. Again, driven by ASI technology. And again, you probably have NDR solutions out there. So what's the advanced thing? And what I wanted to cover here was the idea that often NDR uses things like NetFlow. Again, that's great for visibility, who's talking to who, but the packets have a deeper intelligence in them, and we have the ability to look at the packets, look at them in different environments, even have the ability to see encrypted packets. If you stick us man in the middle or give us the keys, we can actually start to do that sort of thing. Packet capture performance. So we do deep packet inspection at scale. You've seen that technology that we have in terms of vStreams and InfiniStreams for the large-scale environments. So what we do is in advanced NDR, we're recording everything at line rate. Traditional NDR solutions may just copy packets, as it were, after an alert, and just start to collect the packets for that forensics for a later time after it's seen an event. So what about the back-in-time stuff? Okay. The other thing is, of course, the idea of metadata. So the smart data is metadata. You saw the layers of the pyramid. Because that's less data than packets, and it's rich information about DNS lookups or HTTP, we can store that for longer term. But more importantly, it means that we're no longer having to sift through the packets to do our retrospective analysis. We're sifting through the metadata, which is tons faster. And that's proven out. So again, that's why we call it advanced NDR. So that advanced NDR, what can we do with that in the context of exporting that events to SIMs or, for example, Security Hub? Over to you, Josh.
Thanks, Ray. Yeah, so like you said, there are security use cases here, and we have this service called Security Hub. So just wanted to give you a quick introduction what that is. That is AWS's kind of CSPM, Cloud Security Posture Management service. You can see the workflow here, pretty quick and easy to set up, few clicks, and you start getting findings from AWS services, best practice checks, those kinds of things, and then partner findings as well. And then Security Hub also allows you to take action on those findings, right? So what you can do with those, we'll look at it a little more in a little bit, but you know, it's great that you found an issue, but do you want to trigger some sort of automated remediation based on what, say, NETSCOUT found for you? Yeah, so there you go. Better visibility into security issues, easier to stay in compliance. I'm getting the feeling we like these swooping bottom arrows here. So just to give you kind of an overview of how you would how that would work with a finding, how you might remediate it, what would that look like? So first of all, you're detecting, you're getting all that information from AWS's services, AWS best practices, and then from partner solutions like NETSCOUT. That's all coming into Security Hub in our Amazon security finding format, so it's all very uniform. From there, you can sort of filter it, take a look, severities. If you're looking for something in particular, you filter those down into select findings, or what we call insights, which are sort of automated. We think you might want to look at this kind of a thing. And then using a service called EventBridge. I'm partial to EventBridge. I think it's really cool, so I put it in here. This is sort of how you respond, how you get things out of Security Hub, or in fact, a lot of services at AWS. So what that is an event bus, right? So those findings are automatically sent to EventBridge, and then from EventBridge, and we'll see in a second kind of what that looks like, but you can then, trigger Lambda functions, Firehose, streams, you can trigger third-party stuff, PagerDuty, Slack, those kinds of things as well. Oh, there's your targets. I must confess that I do not know all of those icons, so don't test me on that. How many do you get right? No, I'm good. So here you go. This is kind of the workflow overall. This is how the information flows. So kind of on the left there, you see findings from AWS services sending things into Security Hub. You see in the middle we've got our NETSCOUT findings. At the bottom, dozens of other services sending their own sort of checks and information into Security Hub. And then at the bottom there, you've got a service called Detective, which can kind of take a look at everything. Don't have time to go into all of the things Detective can do, but it can kind of help investigate those things. And then on the right-hand side, you'll see we have our findings coming out of Security Hub, again, to EventBridge there, to remediation services like Lambdas, right? You could write something custom to remediate, or what we'd call like a taking action partner. So be that PagerDuty, Slack, however you want to handle the output. It's very flexible in that way. So just to give you kind of the quick and easy overview of Security Hub and its benefits, it has a lot of compliance standards, helps you stay in compliance. You can aggregate all your findings from different sources, different areas. You can also even aggregate all your regions into one region, so it's nice as well. And then you can take action on those findings as they come up. So how does that look with NETSCOUT? I'll let you maybe elaborate on it a little bit, but you can see kind of on the left there at the top, this is the Security Hub console. You can see NETSCOUT findings coming in there. And the nice thing that we have in there, that NETSCOUT built into there, is a nice little hyperlink. Takes you all the way back to NETSCOUT's console. So you can kind of see where that came from and what that looks like. And as you said, packets don't lie. You can get really quickly down into the packets in seconds. Anything?
And basically, I was going to just add to that, the idea that with Security Hub, obviously you have tons of events coming in. So you kind of want to prioritize those events to the ones that are high importance, important. You can do that with Security Hub with the filter. Then you can see, oh, there's some NETSCOUT findings that say, oh, there's some infiltration going on, or there's command and control going on. Then that's the one that you want to drill down and investigate further, and then see, as you can see from the middle picture there, you'll see, okay, that's the device that's been infected. What has it been talking to? So you see that spider. Those are all the things that it's been talking to. And then we'll obviously identify whether those are malignant sort of or normal traffic.
Cool. Yeah, that's all I wanted to say. So
it's me.
Back to you.
Thanks, Josh. So the last but not least component, that third one, we talked about service assurance, which is assuring, and security, which is securing. And what I wanted to talk now about the third one, which was the export. And at the end of the day, I covered this in that clock slide, the numerous use cases that you can do from a perspective of having that smart data. And then if we export that smart data to you, then you can actually go at it, and the world is your oyster for doing your own analytics of that data, putting it into the security lake or security lake, the data lake, and then leveraging that data lake to do your analytics using potentially what SageMaker or any EMR or whatever other components that you might want to do. Use cases are numerous. User behavior analytics, threat hunting, data exfiltration, insider threat detection, security monitoring. Those sort of a couple of examples of what you could do with that data. Obviously, Omnis Cyber Intelligence wraps up a lot of those use cases in its own workflows to save you the work. But you may have specific use cases that you're interested in that we don't do, that you might be just focusing on, taking that data, maybe enriching it with something else, doing your own analytics and coming to your own conclusions based on your own environment. It's really powerful. Of course, not only security use cases, performance use cases as well. You might want to create your own dashboards summarizing how your service is performing, how your data center is performing, how your regions are performing. And you might want to have that wrapped up in a QuickSight dashboard or whatever it is that you might be using. So you want to have that personal to you and your environment. That's what this gives you. Now, from an architectural perspective, okay, this is where I get a bit excited, like Josh does and some of the AWS components. So here's the start of the architecture. You've got traffic mirroring, sending the packets to vStream, vStream doing its smart data analysis, setting that metadata to Omnis data streamer. And what that has is a very simple function to take that metadata and then send it somewhere. And one possibility for sending to is to a Kafka broker. When it's in the Kafka, in this case MSK, the managed Kafka broker from AWS, okay, if you're using Kafka, then you'll know what to do with it. Subscribe to those topics, push that into whatever data lake you want to do, and off you go. Alternatively, a simpler but very powerful thing would be sending it to S3 buckets. CSV format or whatever it is, send it to your S3 buckets, and then it gets really exciting. You can use all sorts of serverless technology like Glue and Athena to be able to take that data, convert it into something that's SQLable, accessible, and then maybe use that simple pipeline and use QuickSight to actually interpret that data and produce your dashboards, as you saw from the previous slide there. Or you can get more exciting, and maybe you might want to enrich that data. So take your EC2 instance information. So the example I have there is pretty simple. The idea is saying our data is very IP address centric because we're monitoring network traffic. When you think of workloads in the cloud, everything's instance specific, VPC specific, region specific, availability zone specific. So if you can enrich our IP information, giving you performance and security with that AWS domain visibility, then you start getting some different perspectives based on, okay, what's the performance of VPC to VPC traffic? What's going on when you go across availability zones? So that gives you that next level of dimension that you don't necessarily have with the raw data. And of course, I like Event Bridge as well. Thank you, Josh. I'm not the only one. But what you could do is when data comes into your S3 buckets, that can trigger an event to start enriching that data, taking that data with a Lambda function. New file in S3, new metadata, Lambda function gets triggered. You start taking that data, doing stuff with it, enriching it, sticking it back in S3, and then using the same pipeline, Glue and Athena, to get your visibility into that environment. Notwithstanding, there's a ton of other stuff that's really rich in AWS, like RDS or Redshift. Beautiful storage locations to do your AI analytics or whatever it is you want to do. Happy days. So I get excited with these sort of things. Anyway, I want to kind of wrap it up before I get too excited. Or Josh likes all these components as well, so he's smiling. Anyway, so I wanted to just cover the AWS and NETSCOUT again, technology alignment. So I think we talked about this in terms of we need to acquire the packets. So we work closely with AWS and make sure that we can acquire them reliably in different architectures. So that's a technology integration. Accelerated migration, well, the migration and modernization competency, AWS puts us through our paces to prove that we are actually applicable in that environment. We help our customers migrate to AWS with the correct tooling in the context before, during, and after the migration. So we've proved that. And satisfied customers, so we've proved that yet again, because we obviously have customers that are willing to talk about how they've successfully have migrated workloads into AWS and monitored them with the NETSCOUT technology from both a security and a service assurance perspective. So kind of ticking all the boxes in that environment. And of course, just to close it down, just 4 points really. Smart data, you know all about it. Deep packet inspection at scale, taking that packets and translating into meaningful metadata to give you the ability to do that service assurance and that security analytics, or that advanced application and network troubleshooting, or that advanced NDR technology. And because it's packets, it can be deployed everywhere. You get that visibility without borders to actually allow you to have faster migrations, more confident migrations of your workloads to the cloud. So thank you very much for your attention. Hope that was a good technology overview. One more thing. You see this T-shirt that I'm wearing? I'm going to turn around there. How cool is that? One of these can be yours. And all you need to do is go to our booth, 306 in the Venetian. It's a bit of a stretch. It might be closed by now, but tomorrow. And just say the words, deep packet inspection at scale, to the people there, and you'll get a T-shirt like this. So,
is that how I get one as well?
You can get one as well. And at the same time, of course, you can get a demo of everything that I've been talking about today as well, if you're interested on further information. So thank you very much. Thanks, Josh.
Yeah, thanks. Go try Event Bridge.